everyone, welcome to the next session of Strength of Materials. In this session, we will be discussing some numericals on the topic of thin cylinders. So let's get started. The first one is a seamless pipe of 1 meter diameter contains a fluid at a pressure of 1.8 Newton per mm square. So the first given data is diameter is 1 meter. Let me convert this into mm. And the pressure P is given as 1.8 Newton per mm square. If the ultimate tensile stress is 200 Newton per mm square, so the maximum value or sigma U is given as 200 Newton per mm square. Find the minimum thickness of the pipe. So I need to find the thickness T. Take factor of safety as 4. FOS value is given to me as 4. We know for factor of safety, the formula is ultimate stress upon the working stress. So let me call the working stress as sigma C. Therefore, 4 is equal to 200 upon sigma C. So therefore, my sigma C turns out to be 50 Newton per mm square. Next, we can use the formula of sigma C as PD upon 2T. So this is 50 is equal to 1.8 into 1000 upon 2 into T. Therefore, T I obtain as 18 mm. Now you must be wondering why I have written this working stress as sigma C and not sigma L. The reason is we have already discussed that sigma C is PD upon 2T and sigma L is PD upon 4T. Now if you observe carefully, I can say that my sigma L is actually less as compared to sigma C. So I can say that sigma L is sigma C upon 2. In these two, if sigma C is maximum and sigma L is minimum, it is always preferable that we design it for the maximum value of stress. Hence, we have taken sigma C. Let's take another numerical. Find the diameter of the boiler which can withstand 100 Newton per mm square stress. So again, I'll take sigma C as 100 Newton per mm square at a pressure of 2.5 Newton per mm square. Take thickness of the boiler as 12.5 mm. I am supposed to find the diameter D. This is very simple. Sigma C is PD upon 2T. 100 is equal to 2.5 into D upon 2 into 12.5. From here I get the value of diameter as 1000 mm, which means it is 1 meter. Next, a cylindrical compressed air drum is 1.5 meter diameter. So the value of D is given as 1.5 meter, that is 1500 mm, with plate thickness 9 mm. So T is given. If the tensile stress is not to exceed 125 Newton per mm square, so sigma C is given as 125 Newton per mm square. Find the maximum safe air pressure. So I need to find P. Sigma C is PD upon 2T. This is 125. P I want to find. Diameter is 1500. 2 into 9. On calculation, I get the value of P as 1.5 Newton per mm square. Okay, a cylindrical shell 3 meter long, the value of L is given as 3 meter, that is 3000 mm, is having 1 meter internal diameter. So D is given as 1 meter, that is 1000 mm, and 15 mm thickness. So value of T is given as 15 mm. Calculate hoop stress. So I need to find hoop stress, that is sigma C. The second thing I need to calculate is longitudinal stress, that is sigma L. Third thing to find is maximum intensity of shear stress. So tau max. The fourth thing that I have to find is change in dimensions of the shell, which means I have to calculate delta D, delta L and delta V. If it is subjected to an internal fluid pressure of 1.5 megapascal, so this will be 1.5 Newton per mm square. Take Young's modulus of elasticity E as 200 gigapascal. So this becomes 2 into 10 raised to 5 Newton per mm square and mu is given as 0.3. Let's start with the first one. Hoop stress sigma C is calculated as PD upon 2T. So this becomes P D upon 2T. On solving this, I get sigma C as 50 Newton per mm square. Second, I need to calculate sigma L. Now you can either use the formula PD upon 4T or you can say it is sigma C by 2. So this directly becomes 25 Newton per mm square. Now the third thing that I need to calculate is tau max. For tau max, we know the formula is sigma C minus sigma L whole divided by 2. So this is 50 minus 25 by 2, that is 12.5 Newton per mm square. Next, I need to calculate delta D. For this, the formula was PD square upon 4TE 2 minus mu. P is 1.5, diameter is 1000, 4 into T is 15 and E is 2 into 10 raised to 5. Here I'll have 2 minus 0.3. On solving this, I get delta D as 0.2125 mm. Next, I need to calculate delta L. For delta L, the formula is PDL upon 4TE 1 minus 2 mu. So P is 1.5, D is 1000, L is given as 3000. This is 4TE 1 minus 2 into 0.3. So this turns out to be 0.15 mm. Last, I need to calculate delta V. The formula is PdV upon 4TE 5 minus 4 mu. Now for V, the formula is 5 by 4 D square into L. So let's substitute everything. I have delta V as 1.5 into 1000. This will be pi by 4. 1000 square into 3000 upon 4 into 15 into 2 into 10 raised to 5. And this whole term will be multiplied with 5 minus 4 into 0.3. On solving this, I get the value of volume as 1.119 into 10 raised to 6 mm cube. This is change in volume. Now on that note, I leave you with this numerical, which I think you can now solve on your own. A thin cylindrical shell, 3 meter long, 1 meter in diameter, is the same as the previous numerical, is subjected to an internal pressure. Here the pressure value has changed to 1 Newton per mm square. Previously it was 1.5. If the thickness of the shell is 12, so the T value has changed from 15 to 12. Find the circumference and longitudinal stresses. Find also the maximum shear stress and change in dimensions of the shell. Take E as 200 gigapascal and 1 by m, that is mu, is given as 0.3. So I think you can solve this numerical. It is very simple. I'll just give you the answers. So these are the answers. I hope you were able to solve it. With this, I end the session on numericals of thin cylinder. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.